Hello there, welcome to my question of the day, which is number 9 in the series that I'm doing at the moment on my Facebook page. Every day I'm posting a question and then I'm going to be doing the work solutions. I'm not saying that my solution is the best, I'm just going to provide a solution for this puzzle. If you're new to this, you've just found me by YouTube, please have a go, press pause, and then I'm going to go through it. Okay, so I think the first thing I'm going to do is I'm just going to read through the instructions in the question. And I think one of the most important things that I can see at the moment are that VW is equal to VW. So VU, is equal to VW. So I know that those two sides are the same, two lengths are the same, I should say, but I know that those two angles at the base of my isosceles triangle that I can see there must also be the same. So I'm looking at that triangle UVW in my diagram and thinking that that's going to be very, very helpful to me. Another angle fact that I can see is that if I look down at the bottom right hand triangle, I know that angle YWX is going to be the same as well because they are vertically opposite angles and they must be equal. And that language is really important, especially if you're studying for GCSE. You've got to know that terminology, vertically opposite angles that are equal. Anyway, I've got to give X in terms of Y and Z. So I've made the diagram just a little bit bigger so that I can draw all over it and write down what I know. Now, these questions can be quite tricky, but as I said, if you write down what you know to be true, then piece by piece you can start, putting that jigsaw together. One of the things that I can see if I look down in the bottom right hand triangle, so triangle YWX, is that there's a straight line. And I know that that little blue angle on the left hand side there must be 180 degrees. Subtract Y, because angles on a straight line make 180 degrees. I can see that I've got a remaining angle of this triangle. So what I'm going to do is I'm just going to express that in terms of the other two angles. Now I know that in a triangle, all interior angles have to add up to 180 degrees. So if I do 180 degrees, subtract my blue angle, subtract X, then that's going to give me the size of that angle. And I'm just going to simplify that. And if I'm subtracting a negative y, that means I'm adding a y. And I can see that 180 subtract 180, that is 0. So I'm just going to left with y subtract x as the size of that angle there. Now, because of vertically opposite angles, I know that I have another one above it that is the same. And because of the fact that I had an isosceles triangle, and I know that the base angles of an isosceles triangle are always equal, I know that that one over there has to also be y subtract x. Which leaves me with a remaining angle in that top triangle there, angle UVW. Again, because I know that angles in a triangle, interior angles, add up to 180 degrees, I can get that angle by doing 180 degrees, subtract y minus x, subtract y minus x. And if I want to simplify that, I've got 180 degrees, subtract y, subtract a negative x means I've got to add x. Then I've got another subtract y, and then again I've got another subtract negative x, that adds x. So I get an expression which is 180 plus 2x, subtract 2y for that angle there. Now, this all looks pretty hideous, especially if you're not as practiced at geometry as I am. And also not as practiced at algebra, maybe. Now, because I need to link x, y and z together, the only way I can really do that is to look at the triangle that also involves an angle called z. Now, in that green triangle, I can see that I have 3 interior angles that must add up to 180 degrees. So that's a fact that I can write down. Therefore, I know that angle z, add angle y, add that orange angle, which happens to be 180 plus 2x, subtract 2y, that all adds together to make 180 degrees because they're my 3 interior angles. So just simplifying that, I don't actually need the brackets. So much easier to just look at by writing that down there. I can see that 180 degrees is going to cancel on both sides because I can subtract it from both sides. And if I just want to tidy up, I can see that I have got z, I've got a y subtract 2y, which leaves a negative y, add 2x, and that all equals 0. Now in the question, it says that I want to express x in terms of y and z. So I must remember exactly what I'm trying to do. So I'm trying to get x as the subject of this formula, of this equation. So I've got 2x equals, now I'm going to subtract z from both sides and I'm going to add y to both sides. And if I do that, I'm going to end up with 2x is equal to negative z add y. Don't know about you, but I hate writing things like that. I prefer to write the positive term first, and then, sorry, it should be y subtract z. Now, because I just want 1x and I've got 2 of them at the moment, I just need to divide both sides by 2 just to keep the balance. Whatever I do to one side of the equation, I have to do to the other side. So my final answer is x is y minus z over 2, and I can see that was option E. If you've got any comments, you can leave them below on the YouTube video, or you can go to my Facebook page and send me a message. It'd be lovely to hear from you. Thanks ever so much for listening. Bye-bye.